Okay, so let's tackle the second case of free fall this time. Okay, an object is being thrown upward. Rex throws his mother's crystal vase vertically upwards with an initial velocity of 26.2 meters per second. Determine the height at which the vase will rise to above its initial height. Okay, so I think it's best if we can try to sketch the problem first. So in this case, you have Rex at the bottom. I don't know why he would do this, but he would throw the crystal vase going up like that. Okay? And we know that he throws it at a VI of 26.2 meters per second. Okay? And we are trying actually to look for Y. But one critical assumption that we can make when an object is being thrown upward would be that at the very top of the flight of the object, your final velocity will be equal to 0. Okay, because if you can actually demonstrate it with any object that you have at home, you can throw it upward. Every time you reach the pinnacle of your flight, your velocity is 0. Your object is hanging in the air. So Vf is always equal to 0. And also we know the other assumption we can make is obviously acceleration, negative g, negative 9.8 meter per second squared. Okay, so that is pretty much our given and required as well. Okay, now we can go to our equation. So we are given Vi, we are looking for Y, we are given acceleration, and we know Vf. So among the equations that we have here, I think the most ideal for us to use would be this one, because that's Vf, this is Vi, that's A, and that's Y, and we can solve for Y. So let's put that down. Vf squared, Vi squared, 2A delta Y. Okay, so we can rearrange this because we're looking for Y. So the solution will be Vf squared minus Vi squared all over 2 times A is delta Y. Okay, so now that we have this, let's plug in our values. We know that Vf is equal to 0. Okay, that's going to be minus 26.2, our initial velocity, squared, times 2 over A, and A is equal to negative 9.8 meters per second squared. I forgot the meter sign at the top. Okay, meters per second. So if you notice, this will be meter squared per second squared. This is meter per second squared. If you cancel all of that out, it will just be meters, which is consistent with delta Y. So let's try to plug that into our calculator. 0 squared minus 26.2 squared all over 2 times negative 9.8. And if we get the equal sign out, this will be equal to 35.02. So delta Y is equal to 35.02 meters. However, sig figs again, this doesn't count because it's 0. This one is a constant, so it doesn't count in the sig figs. The only one that really counts here is the 26.2 meters, 3 sig figs. So, answer, delta Y is equal to 35.0 meters. Okay? So again, for case 2, the critical assumption that you must always carry is that Vf is equal to 0. A while ago it was Vi equals 0. This time, Vf is equal to 0.